Assalamualaikum, Doctor. Today we are going to explore experiment 8 titled Gravimetric Determination of Calcium as Calcium Oxalate Monohydrate. In this presentation, we will walk through our procedure and discuss the data we gathered. Now, let's look at the core of our project. Our main objective here was straightforward: to isolate and measure the calcium content in an unknown solid by precipitating it as calcium oxalate monohydrate. To achieve accurate result, we use a method called homogeneous precipitation. By using urea in an acidic solution, we could slowly raise the pH, which allows for the formation of large pure crystals that are much easier to filter than those formed by rapid mixing. Now, allow us to introduce ourselves as the members who conducted this experiment. My name is SYAHIRA with a matrix number of A216762, and my role is editing the video, being the narrative of this video, and also composing of our conclusion.
I am NAJWA, A217207. I am slide editor.
Hai, nama saya Muhammad FAIRULZATUL HIFZHAN bin Sabri, bernombor metrik A219814, role sebagai recording calculating.
Moving on to our procedure, we started by preparing our samples. We weighed roughly 1.2 to 1.5 grams of the unknown solid. We also made sure to weigh the mass of filter paper and the mass of watch glass. Then, we dissolved them in a beaker using deionized water and 3 molar hydrochloric acid. Once dissolved, we quantitatively transferred this solution into a 100 ml volumetric flask and diluted it to the calibration mark. By quantitatively transferred, we meant that we rinsed the beaker with deionized water and pour it in the volumetric flask with a minimum 3 times of rinse to make sure all the solution fill in the flask. In the next procedure, we pipette a small portion of solution to rinse the pipette, rinsing the pipette by rotating it and then discard the washing, as shown in the video on the left. After we had rinsed the pipette, we pipette exactly 25 ml aliquots into 3 separate beakers, and then we add 75 ml of 0.1 molar hydrochloric acid to each beaker to dilute the solution. Next, we added 5 drops of methyl red indicator, which turns the acidic solution pink. Then, followed by ammonium oxalate, which we measured and added 25 ml of ammonium oxalate into each of the beakers. After that, we stir the solution with glass rod, and after finish, we remove the glass rod and rinse it with distilled water. The crucial step was adding 15 grams of urea and heating the mixture. So, we weighed 15 grams of urea and add to each of the beakers while making sure that all of the urea must be poured in the beaker. Then, we covered each of the beakers with watch glass. We heat the solution using hot plate and stop heating the solution once the pink of the solution turns to yellow. This meant that as the urea decomposed, it neutralized the acid, turning the indicator yellow and causing the calcium oxalate to precipitate slowly. After the heating part had stopped, we filtered the hot solution using suction, while also taking note that the filter paper must be wet before filtering. 2 times of 10 ml ice cold water is used to rinse the beaker, and we poured it to the precipitate. Next, we took the filter paper out with precipitate using rubber placement and glass rod. Then we put it on the watch glass. We dried each of the precipitate in oven for 24 hours. In the next day, after 24 hours, we take the precipitate out from the oven and then record the total mass of all the sample in our datasheet. In and out, here are the results we obtained. First, looking at our raw data, we recorded the mass of the precipitate for our 3 trials as 0.52 gram, 0.53 gram, and 0.48 gram respectively. Now, in the question part, by using the stoichiometry of the reaction, we calculated the gravimetric factor to be 0.2743. By applying this factor, we determined the mass of calcium in each sample. This allowed us to calculate the weight percent of calcium for each trials. The values are 11.05%, 11.27%, and 10.21%. Now, this is our manual calculation for the mean, standard deviation, and the relative standard deviation. Next, for the statistical analysis using Microsoft Excel, it gave us a mean weight percent of 10.84. The standard deviation was 0.5594, resulting in a relative standard deviation (RSD) of 5.16%. This proved that both our manual calculation and Microsoft Excel was aligned. In conclusion, we successfully achieved our objective to precipitate and quantify calcium as calcium oxalate monohydrate. Based on our analysis, the unknown sample contains approximately 10.84 calcium by weight, with a relative standard deviation of 5.16%, showing that our results were consistent across trials. The outcome of this experiment highlights the benefit of homogeneous precipitation. By generating the precipitated ion slowly, we minimize errors and obtain pure crystals that were easy to filter. That's all from us. So, we hope this presentation has provided a clear and helpful overview of the precision required in gravimetric analysis. A key takeaway we want to leave you with is the crucial role of the urea in this experiment. Its thermal decomposition allowed us to raise the pH gradually, ensuring the formation of large pure crystals that are essential for accurate results. We trust this insight into homogeneous precipitation serves you well in your future analytical work. Thank you for your time, and Assalamualaikum.